just put it on record. So, is my voice audible clearly?
Yes, sir.
Good. So let me share my notepad. So in the last class, till the last class, what we did is more about representing data in different manners and manipulating the actual data itself. Right. For example, we we understood how different data can be represented in any model or inside a computer system for our purposes. And then what we did was using linear algebra. Basically, all the representations were the entities or the concepts used in linear algebra, right? A vector, a scalar, a matrix, or a table, or a tensor. All those things are some basic structures inside the linear algebra framework. And then, since the data is represented in that manner or using that methodology representation, we have we tried to understand some basic operations that we can do on those data. For example, for a vector, if you want to find out the similarity between any two vectors, how do you do that? Using the dot product. Or if you have a representation in terms of tables or matrices, right? Then what you can do, if you want to change the perspective, you use the transpose operation. Or if you want to process all the columns and rows in one single go, you do the matrix multiplication, which is essentially the dot product individual with respect to individual columns one by one. So the numbers that the final result will holds after performing the matrix multiplication is nothing but a collection of dot products between two individual between any two pair of vectors, right, present in both matrices. I hope you were able to make that sense when I was teaching it yesterday. So once we understand how data is represented, how it is manipulated on all those things, now comes the next part where you need to understand what the data is trying to tell you or what inferences that you can draw from the data. For that, we use the analytics part of the data processing, right? What is the analytics? It is basically trying to figure out certain properties in the data given using some standard matrices, some standard metrics, not matrices, metrics. What do you mean by a metric? It is something that represents a particular property. Okay, it can be anything. If I tell you that to select somebody into my, say, for example, physical training camp, I need the height to be at least 5 feet 6 inches, let us say. Okay. In that situation, the metric to measure the candidate or to select the candidate becomes the height. The height represents a metric, which is a selection criteria, right? So in the same way, we can define many metrics. There are some standard metrics that are used in the industry or in any statistical method. And those methods we are going to cover some basic ones which are necessary for us for our next discussions. We will discuss them. These are part of the basic metrics used in any statistical analysis. All right. So you must have this perspective when I tell you that linear algebra is the representation and basic manipulation of the data, and the statistics is the analysis or the churning of the data to get some insight into it. Okay. And based on there are many concepts, like huge number of concepts uh, and metrics that describe the data. However, we will not be covering all of them. For example, there are some Jack-Bera test and even autocorrelation and those concepts, right? And apart from that, there is there is a metric called Z-score test. There is a metric called ANOVA, which is basically analysis of variance. There are many things. There is an R-square matrix for linear regression. There are many things, but we will be looking at the basic ones today. Tomorrow also I'll discuss about the statistics itself. It is a 2 day part that I have planned. For today, we will be discussing and gaining the perspective towards the basic metrics, which are, I will list them out. One is, most of you already know the names and everything, even the basic understanding and formula, I guess you already know. One is mean, another is median, another is mode, and then we have something called variance. Then another thing we have is standard deviation. Can you guys tell me how many of you already are familiar with all these words? Two, three, six, seven, eight. Okay, cool. I think most of you already know the names at least. Now, I will explain it using a sample data, and then let me try to give you a perspective of how do you take these metrics into the AI landscape. Okay, in any data analytics part, how do you take these or interpret these metrics? Let us try to understand. Okay, because knowing the normal statistical understanding is one thing, and knowing how to incorporate that into our analytics is another thing, right? So for that, let us try to understand these concepts in a different view. So let me take one small example. Say for example, heights. I am taking this, sorry, yeah, heights is equal to, let me define a set, maybe 5.0, 5.1, some 5.5, 5.4. Let me take only this much, right? So I'm taking this as an example. Just assume that it is a list of values of heights for how many? Four students or four people. Okay, we have taken a sample. We have collected this data by maybe measuring the heights of some people, and then we have tabulated it into this particular variable, whatever, right? Into this list. Now, generally the basic idea, let's go through that quickly. What is it? How do you calculate mean? Mean is equal to what? So if I indicate these items, then how can you write it? 5 plus 5.1 plus 5.5 plus 5.4 divided by what? Divided by how much? 5. 5. Is it? Why? 1, 2, 3, 4. There are only four data, right? Four
Sir, four.
samples. Yeah. So what are we essentially doing here? We are actually summing up all those values and then dividing it by 4 means we are trying to average out the height value, right? So this is what the mean is. This understanding, I guess everyone has. Mean is nothing but an average, right? Now, if you look at this, now if you already know that, okay, most of the people in this, say for example, we have a school, maybe a classroom, and when we say when we have a collection of height of all students, then most of them are in this height range. Say they lie between 5 to 5.4, some values repeat and such things. Then the general understanding, if I close your eyes and let one of the students from the class walk in front of you, you don't know who is coming, right? Then if I ask you to predict what could be the height of that person, your eyes are closed, right? Hold on. Your eyes are closed. Now you have to predict the height of the person standing in front of you. But you have been told that that person is from this particular class. Okay. Then what would be the general answer that you will get, or you can make? You will say you already know the average value, the mean value you already know. Then the blind guess that you can make is what? The mean value, right? What is it? 5 plus 5.1, 5.5 plus 5.4. Can anyone make a quick calculation? It is 10.9, 11, 16 plus 5, 21 divided by 4, right? It is how much? 5.2. So this is the blind guess that I can make. The baseline guess, right, is somewhere, the person could be somewhere around 5.2 feet would be the general answer. Here there is no intelligence, nothing. Simply based on the average value of heights in my classroom, I am just telling that particular number, right? Just give me a minute. 1 second. Yeah, sorry about that. Right? This is the basic understanding we can get, or the basic prediction that we can do towards any data, right? It is, I have just taken the example towards the height. Anything you can make. If you have 20 items with some prices, if I ask you what could be the price of a random, or what is the range of any item's price, you simply tell me the average. It is roughly around 1000 rupees. However, individual element may not have the exact price, but the average price you say, correct? So that is there. However, one problem with this approach, taking the mean value, is that if you have one single value, okay, that is totally out of the range of these values. Say, for example, I have a person with height of 8 feet, right? Now, what about the mean? It is going to be how much? 21 plus 8, 29, right? 29 divided by 4, sorry, 5. What is the answer? 5.8, right? Is it correct? Yeah.
Yes, sir.
So if you look at this one person is very tall. That doesn't mean the average, on an average, people are this tall, right? 5.8, you can't even find one single guy who is above 5.4 except 8 feet, right? So now the mean value has changed, and it is very unlikely that I will get a person standing in front of me who is of height 5.8, right? So this metric mean may not be helpful in some data sets where there are some extreme values. And those extreme values are often called outliers. They are outside the range of other normal data. The similar thing can happen when you have a person of, say, 3 feet. Then also the same thing happens. Correct? So to counter that, how can I mitigate that effect of an outlier in my prediction model? What I will do, I will use another metric called median. Okay, what is median essentially? What it does is it arranges all this data in a ascending order, say 5, then 5.1, right? And then 5.4, and then 5.5, then 8. What it does, it calculates the number of elements. Okay, if the number of elements are in odd numbers, we have odd numbers here, right? 5. Then what it does, if the number of elements are represented by n, then n plus 1 divided by 2, this element it will pick. We can say that it is a middle value that is available in the range. Okay, then what is it? 5.4. This value it picks up. Now, the outlier has not affected the value of median too much, right? 5.4 lies in a reasonable range compared to the numbers that we have, right? It is very unlikely that out of these 5 numbers, I will get the person of 8 feet in front of me, because the probability is very less, 1 by 5. However, getting somebody in the range of these values is quite high. It is 4 by 5. Probability is quite high, right? The odds. That is why median gives you a robust metric when outliers are involved. Is it clear? If we have even number of samples, then what we do? We do n by 2 value, right? Plus n plus 1 by 2 value. We can write it like value of n by 2th element, n plus 1 by 2th element, right? And then average them out divided by 2. That will be the median value for any set that contains even number of elements, because there is no middle value specifically, right? So what we do, we pick the middle two values, take the average out of them, and that will be our median. Fine. I hope you are getting the concepts. Yes.
Yes, sir.
Okay, cool. Now, these two metrics are helpful for any numerical columns. Why? Because the average, finding out the average or the mean value or the median value requires some mathematical operations like summing them up, dividing by the number of elements, or finding out the total number of index, the number of elements and dividing it by 2, all these things, right? Or if the number of samples are uh, even numbers, then we have to do this particular calculation, averaging out. So ultimately, these are all mathematical operations which require mathematical operands. That means they can work only on numbers. What if I want to find out something like uh, whether that student that stands in front of me wears a glass or not, let us say, right? Then what are the possible values for that particular feature? We can have either a yes or no, right? I will have the data in such a way that the data should contain what? It should contain the name of the student, maybe, and then height would be, then wears a glass, right? Now, the height is a numerical, but here we can only have a yes or no. For these kind of values in the data, we cannot calculate either mean or median, right? Not possible. These are not possible for this kind of data, correct? In that situation, if I want to predict whether the person wears a glass or not, then I will look at how many people wear glasses in the class. Out of five, if I have say 3 or 4 people wear glasses, right? Then it is highly likely that the person standing in front of me may also be wearing a glass, because out of five, I have a higher chance that I will pick somebody from these 3 to 4 people. Only 2 people are left out who do not wear a glass, and the chance of guessing that is comparatively guessing that right is comparatively less, right? In that situation, the general intuition is what? Pick the highest value in that particular feature, right? If more people wear glasses, pick that value. If you in your class you have only 1 or 2 people wearing glasses, then you will pick the doesn't wear a glass answer. Why? Because it is more repeated. Many people don't wear it in your class. Hope that makes sense. So the that particular value which is repeated more is called a mode of that particular feature. Okay, is it clear? Let me give you a use case for all these things, right? Why do we need these metrics? The major purpose or the major usage of these metrics is when you get some data from some data source. Let us say you downloaded a data set that contains multiple readings of a sensor, maybe, or something like this, a classroom database, right? Then, upon inspecting the data, you found out that some values or some for some students, certain features are missing. For example, for student A, I have everything. Student B has height value missing. It's not there. He has this value, maybe it is there. Okay, for some student C, I have the height value, no issues, but I don't have the value for his eyesight related feature. May be possible, right? During the recording of the data, while entering the details, maybe these things have been missed out, or the student hasn't entered that particular value, and whoever the data operator was, he also missed it while entering. He didn't force it, right? In such situation, some students may have some missing features. Then calculating anything or predicting something doesn't make it, it actually essentially breaks your model. How does the model look at the missing data, which is not even a number? There is nothing, right? In such situation, we need to fill these values, these missing values, in some manner which doesn't affect the inclination of the data, or whatever the data is trying to tell, or the trend that the data is following, that should not be broken. Okay, you cannot fill in some random value. Say for example, here in the height column, if what if I type in 9, it totally breaks out of the trend, right? It affects my calculations in a very huge manner. Correct. What if I write something else here? That also can affect my data. In such situations, what we do, we simply replace these numerical columns. If the column doesn't have an outlier, if the value is distributed in a really nice manner, right? I will show you what is the distribution, how to look at that. But if the values are distributed in a nice manner without any outliers like this, something like this instead of this, right? In such situations, we fill these missing values with what? Mean values, because mean value still gives you the proper answer. No problem in that. However, if there are outliers in the numerical column, then you should replace these missing values with what? The median, because median is resistant to outliers. Okay. For what about this column? It does not contain any numerical values, right? It contains only two categories, yes or no. The values are divided in only these two categories, and such columns are called essentially categorical columns, right? And these category for missing values in categorical columns, you will have to use what now, which makes more sense? Mode. Whatever the mode of the existing data is, pick that value, replace the missing values with mode. Sometimes even these create nonsense in the model, but don't worry, these are the basic idea, or in the initial simplest way of cleaning the data. These are the metrics used. However, in advanced models, we can also do something like imputations. It is called imputation method. And in imputation, what they do is they simply predict the missing value using some another machine learning algorithm. Okay, those things don't worry about them, and they are part. They can be studied because they require a lot of understanding in the statistics as well as machine learning to do that, and we cannot cover it in this basics class, right? So this much is good enough. I hope you guys understand what it is, what we are, all these concepts. I hope you are clear with them. Yes, guys, are you clear or not?
Clear, sir.
Okay. Then shall I move on to the next concepts, the remaining two metrics? We have understood these three, right? These three we have covered, variance and standard deviation. Now, just take this value. Let's assume this value, or even you can consider the standard deviation. Sorry, not standard deviation, even median value also you can do it. No issues. Let us say in the same example of the prediction of the height of the person in this same game, right? Imagine I have a mean value. We have found out the mean value, right? Let's ignore the outlier. Let's take this much. We have 5.2 feet as the average height, right? So my prediction would be whoever comes in front of me, since I can't see them, I'll simply say 5.2 feet. Okay. In that situation, I'm making an error, right? There is no person having maybe 5.2. Yeah. In this entire sample space, there is no person having height of 5.2, but I am roughly predicting 5.2 because of the average, right? And then on that mean value, for any person that stands in front of me, I am making an error to predict the height. Correct. Now, how to measure that? How much error is coming up? If we are considering the mean value, then how much error is coming up over the entire data space? That is what we call the variance and also standard deviation. These two are not same. Okay, standard deviation. You can understand what a variance means by its name itself. Variance, right? It is the change of data with respect to the mean value. Okay, how much the data changes with respect to the mean value. However, variance, we have a formula. The problem with variance is that if you simply measure the error and calculate, let me take a small example. It is 5.2, 5.3, and 5.4. Right? What is going to be the average here? It is 5.3, obviously, right? Correct. Now, if I am using this value as my prediction for 5.2, what is the error? I have to subtract this value from this, right? Or I have to subtract the actual value with mean. It is going to be how much? Minus 0.1. Here my error is 0. Here it is 0.1. Correct? Now, if I try to find this out, how much error I am making over the entire range, if I sum these things, what am I going to get? 0. Means what? Based on this simple metric, right? I'm not making any mistake at all. My error is completely 0. Doesn't make sense, right? That means what? This simple calculation doesn't give me the whole idea about how the errors are distributed or what is happening inside in my prediction. So to counter that, what people did is they calculated this difference, squared it in every calculation, and then added them. Okay. With that, they divided the error over the total number of samples. So the essentially the variance that we have, the variance formula, there is a symbol for this, which is called sigma square is equal to, this is the summation, you already know that, right? If I take the sample space to be x and x bar as the mean value of the samples, right? If I indicate each sample as xi, then what is it? I is equal to from 1 to n over each sample. I need to calculate what? Xi minus x bar. This is the error here. This is the error term, right? Square this difference. I get some number, positive number in every term. I'm going to get a positive number because it is being squared, and then sum them up and divide that value or average all those values over the total samples, that is n. This is the standard formula for variance. Okay, if I have to do this for this particular sample space, what should I do? Look at this. I am expanding this summation, right? If I do that, I have totally 3 samples. So the first iteration of the summation is going to be how much? 5.2 minus 5.3 squared plus 5.3 minus 5.3 squared plus 5.4 minus 5.3 squared, totally divided by 3. Total number of samples is 3. So the answer is going to be how much? Minus 0.1 whole square plus 0 square plus 0.1 whole square divided by, is going to be how much? Can somebody answer? Yes. How much is it going to be? Nobody has calculated. How much is it? Okay. Okay. Some 2, 3 people. Fine. Cool. At least you guys are listening to the class, right? All right. So this is the variance that we have upon what this particular data set, right? However, one problem with this is variance has no meaning at all. If you look at it, no physical meaning exists for variance, right? Because the term, the unit that we have for this particular value is what? It is height minus height squared. Height minus height squared. Height minus height squared, right? So it is going to be what? If the height is in feet, then it is going to be square feet, isn't it? Or feet square, which doesn't make sense because people's height, square feet, we usually use it for area. And what does it even make sense? Correct? It simply tells you a number. So for this reason, what people did is they simply took the square root of the variance just to bring back the unit, right? Is nothing but standard deviation. Okay, so essentially the formula for this, it is sigma, instead of sigma square for variance, it is sigma is equal to, what is it? Sigma 1 to n xi minus x bar. X bar is the mean value, right? Square divided by n and the entire expression under root. Now what happens? This square or the unit that is mentioned in square feet gets rooted and we get the unit in. Okay. Can somebody calculate the square root of this value? What is it going to be? Yes, 0.047. Okay. Now this is the feet. This is in Okay. Now, generally, when I say this, it means what? My value, now I can tell you one thing. If I ask somebody to, if you are supposed to predict the height value, then you can say it is 5.3 feet plus or minus 0.07047 feet, roughly near to 0.05 feet. Right? It has given you a little bit of headroom. The errors that you the errors are incorporated in this particular range. Okay, this is what standard deviation is. Now, these things actually matter a lot, because when we are going to build the linear regression model, this is what we calculate. Standard deviation and variance is what we calculate to understand how much error is happening and everything. So this understanding has to be there. Is it clear for everyone? One second. What did you guys just tell me the value for this one? Second. My screen is gone, is it? Yeah. How come you guys got 0.047? Yeah, even zero. The root of 0.006 is 0.077, but that is an approximation because 2 by 3 or 0.02 by 3 is an irrational number, right? You are leaving out zero point 0 some sixes in front, like 0.006666666. It continues. And since you have taken only 0.006, the answer you are getting is 0.077. That is why I told you to calculate this value, right? It is going to be a little more higher than that, just to avoid the approximation errors. I think it must be the double of this, somewhere around. So how much is it? 0.081, correct? 0.081. This makes sense because 0.047 of standard deviation is really off. Correct? Okay. Shall I take you over to the collab now? Only these are the concepts that we are going to cover for today. Tomorrow, I will discuss about uh, an important metric called correlation, and also there some more, right? For today, since we are already up the time of 1 hour almost, but we started 10 minutes late, I'll show you the execution part as well. Just let me know whether you are clear with the theory concepts. If you are, I will move on to the execution parts. Sir, understood. Is it visible to everyone? It is, right? Okay. You open the chart and everything in the other screen. So here I have taken the same data set that I had taken in the previous one. It is not exactly the same. I have taken some random values, right? Now, just give me a second. I'm sorry. Cool. So this is going to be very straightforward. I have taken the array as heights, right? And then there are some, uh, let's print this out so that we can understand. And there are built-in functions for this. We will not have to calculate everything by ourselves. If you want, you can simply do something like for item or for value in heights, right? You find out the sum plus equal to something like this, equal to item, okay? And then, sorry, value, right? Equal to value. And then once after the for loop, you can divide this sum divided by total length of what? Heights, correct? So with this, you can calculate what? Sorry, unsupported operators times s for plus. Sorry, this you can do heights of value. Oh, this is not a list, is it? Yeah, it is an NP array. Then I have to do something like oh, sorry. Okay. This I actually did not have a variable called sum, and I was trying to do the compound assignment. That was the error. Fine. So this is the crude logic that we can use to calculate the mean value. This one, right? 5.566. However, we don't have to reinvent the wheel again and again, right? Wheel is already invented. So for that, what we can do, we can simply use a function, built-in function that is already available in NumPy, np dot mean of heights. You simply pass in the data set. So this will also give you the same answer, 5.566. Make sense? Now this is the mean. So let me print it separately. Print mean value, right? Then, yeah, mean value. And then let's do the same thing for median as well. np dot median function is there, simply pass in heights. So you got what? Median value is 5.5. Now let me do this. I was talking about the outliers, right? Here I have taken 7 as the outlier. Now, if I remove this, look at this. Mean value has come down to 5.38. Now, in this situation, even this mean value can make some really good predictions, right? There is no outlier present in the data. And even that can actually reduce the error as well to a great extent. However, if we have look at this median value 5.45. Now, if I include some 8, right, an outlier value, some great curly has come, I guess. Now, if you look at this, the mean value has pivoted towards the right hand side of the graph to the higher range. It has changed the value, but median value is somewhat similar. There is not much difference to the median value. Can you make sense of this? Right? However, for mode calculation, we don't have a categorical thing here. Can do that using a different library. Even a NumPy also doesn't support mode calculation directly because it is not a numerical calculation, is it? Right? And NumPy is all about numericals, numerical Python. So for that reason, let I will simply skip the execution, or if you want, I can show that too later. Right? There is something called statistics library. In that you will have to use to calculate the this one mode. However, you can calculate the mode on numerical column as well, but it will be something like the value that is repeated more than once. For example, in this particular data, the mode value is going to be how much? 5.1, 5.2, 5.5, 5.61, 5.1. 5.1 is repeated more times, right? This will be the mode value here. Fine, don't worry about it. So that is that. After that, if you want to calculate the variance, then for that also we have fixed formula or function written already. Variance value is what? NP dot VAR of heights. Okay, variance value 0.759. That is similar, close to 7.6. And this variance value is this so much because of what? This outlier. If I simply remove this, now what? Look at this. The value is very tightly coupled because since the mean value is 3.5.325, most of the values are ranging from 5.1 or 5 to 5.6. So the variance value is also not varying so much, or the value is not that great. Let me do the standard deviation as well. And here there is a small catch that I need to tell you. Standard deviation np dot std heights. Look at this. Can you see the contradictory values here? When we saw the formula in the theory part, when I was explaining just now, standard deviation is the square root of variance, right? So the variance value is supposed to be more compared to standard deviation because we are squaring this standard deviation to get the variance value, or taking the square root of variance gives me the standard deviation. What is the square root of 4? It is 2. So if the variance is 4, standard deviation is supposed to be 2, correct? What's happening here? Can anybody tell me? I'll wait for this. Yes, this part. Why is variance value comparatively lesser compared to standard deviation, even though it is the square of this standard deviation? Square values are higher comparatively, right? They should increase the value. Anyone? Should I be asking, picking names? Let me do that. Hold on. How about Faizan? Faizan Raza. I don't know. Okay. Can I ask Kushal? Kushal DK? Kushal? No? Okay. Ananya? Don't know. Okay. Niriksha, can you answer? It's a simple thing.
Sir, when we take square root of numbers which is less than 1, then the answer will be less.
Answer will not be less. If you are taking the square root, it is going to be more. Right? Yeah, that is the answer. Honestly, right? The answer lies in the mathematics. Here, the standard deviation and variance value, they are in the decimal points, right? When you square a decimal point, Obviously the square value is going to be what? A smaller value. If you do zero point 0.1 square, we did that right in the theory part. 0.1 into 0.1, the answer is going to be 0.01, which is comparatively lesser in magnitude. Correct? That is what is happening here. That is why we are getting variance value lesser, because the value itself is in decimal points. If the value was not in decimal points, say for example, I had standard deviation of 10, then the variance would have been more. Do you want me to do that? Say, let's take some 5, 6 values, 10, comma, 20, comma, 45, comma, 30, comma, maybe 18, comma, 16, right? Now, let me run the same code. Now look at this. Mean value is 30.5, median value is 25. Variance value is very huge compared to standard deviation. This makes sense, right? We have some 17 odd numbers and then it is squared into 294. Okay. One more thing that you must understand is this standard deviation is in the scale of the value given. Like since the value is given in say 10, 20, 45, 30, 18, 60, I have already discussed that with respect to height. Imagine these to be the prices of houses, let us say. Okay, there are multiple houses and you are calculating, you have tabulated their prices. This one is 10 lakhs, 20 lakhs, 45 lakhs, right? 60 lakhs. In that situation, when I say what is the average price or what could be the price of a house, then I can safely say that it is something in the range of 30.5 lakhs plus or minus 17 lakhs. Makes sense. Okay. However, you cannot make sense of this number. Can you? 30.5 lakhs plus or minus 294.5 lakhs? No, right? However, this variance is designed in such a way that it is a matrix designed in such a way that when it is used in any regression model or any model, it actually uh, amplifies the error that is being produced and adds a huge penalty to the prediction model. That is the idea here. It brings down the errors when optimizing in a very fast manner, because every error is putting is put inside a is put behind a magnifying glass here, right? The error is squared. That is why you get this high value with respect to variance. But the standard deviation is in the normal scale of the data itself. The data is in 10, 20, 30, 60 lakhs. Then the answer, the standard deviation, the variation will also be in the range of lakhs itself. Okay. For variance, you cannot explain it physically, what it actually means. Okay, keep that in mind. I just did something here just to make you understand, get a clean idea, right? Don't worry about this code because it is simply to plot the image. Let me do this. I had, it's okay, no issues. Can you see this? Just what a little larger. Do one thing. I reduce the height itself. Is it? Yeah, the entire plot is visible, right? Now this, I think you can make use of this to understand the concepts. All these blue dots, they are representing different data points that we have. Okay. Here I had, it was written for height and student number, the height of the students, the previous data set. But don't worry, these names you can ignore them. Here actually we have house number 1, house number 2, house number 3, 4, 5, 6, and then prices in lakhs. Okay, if you want here, I can simply this price in, right. So if you look at this, the dotted line represents mean value. Still here also it is feet. Don't worry, it is lakhs. Okay, and then the solid line represents the median. Okay, blue dots represent the house price, houses and their price, corresponding price. Fourth house has a price of 30 lakhs roughly, right? And then this band that you can see, it is the standard deviation. Okay. However, these two are kept as outliers which lie outside the standard deviation. Okay. It's a normalized calculation, right? Standard deviation. It essentially is divided by n, and that is why it is these values, extreme values are lying outside. Okay. And the variance, I'm simply tagging it. I hope this makes sense. Yes or no? Okay. So if you have any doubts, you can ask away. Stats is really cool, you know, gives you It makes you understand many things. I use it many times to understand my students' marks in an exam and all those things. No one has a doubt. If no one does, then how many of you have filled out the feedback form I have shared? Or how many of you have not? Check. Only two, three, only two, three people? Actually, no, because I have got some 11 inputs already. Right? Let me just. Well, your names will not be shown because it is not recorded at all. Yeah, I got some more 14 responses. Why I'm doing this with you guys is just to address a few if there are any concerns. While I am doing this, you can ask your doubts, okay? If you have anything. Data is not being synced, is it? 11. I was supposed to get more. Yeah, now I got it. Synced in the Microsoft form. Okay, some of you did not fill these. Here to understand practical teaching, easy to understand, clear and easy to flow. Okay, cool. Well, okay, challenges. Sometimes the coding concepts are a little difficult to understand quickly. Okay. Um, if I'm going to catch up. Class recordings, I'm already sharing. No issues in that. Apart from that, there are no other problems. Nothing but some kind of issue. Was it was very good. Okay. No serious feedbacks about any problems, I can say. This I will take it into consideration. Okay. What about this suggestions? In class recordings, I'm providing it. In coding, please write the program first and then explain it step by step clearly. Okay, we can do that. When we do this part, right? If we do it like this, what actually happens? We can do that, no issues in that. But I am assuming when I am doing the coding, you are also parallelly doing it in your Google Colab. So if I simply type the code and then explain, when I am explaining, either you are typing or you are not. If you are typing, it takes away the attention towards the explanation, right? And if you are not typing, then after the explanation, you will not get enough time to type it and run the program. But when I'm doing it along with when explaining, I'm typing along. Comparatively, it is easier. It is what I thought, because smaller lines, each line I type and I tell you what is going on. By that time, you can type one single line. Doesn't take too much of distraction. So yeah, that is what I thought. But I'll think about it. Okay. Please teach more practicals. You will regret this because the later stage, right? When we go into the next level, this is going to be the largest part. In unknown information, I'm very little bit knowledgeable, so that the class is understood, but some topics confusing. Okay, you could have mentioned what the confusing things, whatever it is. All right. Should I share another link that will ask you guys regarding any unclear topics? If you want some more explanation about them, those things, let me do that. If you want, we can cover some topics once again. Okay. I'll spend some time to address that. And those who have not and the filled the form, please go ahead and do. Okay, cool. If no one has any doubt, shall we end the meeting? Yes. Okay. And one more thing, I am planning to launch the enrollment for the second batch. However, the batch will not start until your batch is over. Okay. The idea is to train or introduce at least some 50 odd students on the basics, so that when I start a really good an intermediate level course in future, then at least I will have these 50 students who already have some basic knowledge that have been guided by me, and some of you may enroll in that course, then it becomes easier. Okay, at least that is the idea. So if your friends are planning to or miss the chance to enroll to the course, you can tell them. I will share the link soon. Maybe in 2 or 3 days we will do that. Okay, just so you know, I'm telling you. Okay, cool. Good night. Let's meet tomorrow.